Good afternoon, ladies and gentlemen, germs and amoeba, to the AP Computer Science Method Summary, Chapter 8, Section 8 lecture. Due to circumstances for a field trip, I won't be in class today, but if you think you were going to get out of your educational obligations, gotcha. So without further ado, let's begin. Now, class or static methods. We looked at them a little bit yesterday, and we talked about the definition of each. As you recall, class methods are sometimes called static methods because they have the keyword static in their heading. A class method is called with the class identifier, not with an object of the class. This is practical when there's no need to make multiple objects of a class, and a good example is Java's math class. If you think about the constant pi, it never changes. No matter what math class you're in or what application you're working with, it's still 3.14 ... Same thing with the square root and power functions. They never change. There's no reason to create an object. If we look at this example, we have a class called demo, and we have a class called Piggy, and all these are static methods. There are a few of them: init data, add data, and show data. All of them work with a private variable that's called savings. Because they're static, we know they're class variables. They're not going to be able to be made into objects. If you look at the top under the class demo, there's our driving class. You'll notice that the methods init data, show data, and add data are called using the class identifier Piggy. So Piggy.initData runs the init data function, which sets savings to 0. Add data adds value, in this case in the form of a formal parameter s, which is passed an actual value of 1200 to the original savings variable. And show data, which gets called both before and after this add data call, displays savings followed by the actual value of the variable. Because there's nothing here that can change, this is just a class. It's not an object application. This is in contrast to it, for instance, for our bank class, where we can indeed create multiple objects for multiple values. So object or non-static methods, well, objects are called non-static methods because they don't have the keyword static in their heading. Remember, this is our major difference. Object methods are meant for those situations where multiple instantiations, examples of a class, must be constructed. Again, think back to the bank. An object must be constructed first with a new operator, and then the object methods are called by using the object identifier. If we think back to the bank class, for instance, we created accounts for both Tom and Sue using different starting balances, one with the default constructor and one with an overloaded constructor. In this case, if we look at Piggy now, no longer do we have the static keyword under its class, simply private and public. This means that this is no longer a class, or just a class, but also an object. So I can create a new object, Tom, of data type Piggy. When I use the new keyword, it calls the Piggy constructor, which automatically initiates the value for savings to be 0. Now when we call init data and show data and add data, it's off of the identifier Tom where we created our object, not off of Piggy, the class name. Which implies then that if I created another Piggy object, for instance Sue, I could add different data to her particular balance, and she would have a different balance stored. So we could return different balances from the two, just like in our bank class. Now, public methods, well, it just means you can access it from anywhere. If you think back to all of our other applications, such as Scanner, for instance, you can access that even though you're not inside of the scanner class. So if I want to take in data, I can create a new scanner. I can grab those methods and access them within whatever program I write. Most methods are indeed public. Those that aren't public are private. We call them helper methods. If you think back to our picket fence, for instance, you had a function called picket, created pickets, and then you had a function called picket fence. And what it did is it used picket in order to create the fence object. This in turn drew the fences on the screen. Because picket never needs to be called by anything except for the fence method, it was declared private. There's no reason to access it outside of the class. They're just subroutines for your program. Another example of a private method was the card deck program that had the shuffle method. There was no reason for anything except for the constructor to call shuffle, and therefore it was described as private. Now, if you recall, void methods do not return a value, and they use the reserved word void to indicate that no value will be returned. If we look at this function, show data, we don't return any data at all. We only show it. It's just output to the screen, a system.out.println command, just both for the name of the savings, which we would assume to be attributes or class variables that have already been defined. As you recall from yesterday, however, just because we have a void doesn't mean we can't use the return command. As a little note, if you use a return command under a void function, keep in mind that you can't actually put any data after it, but what it does do is it exits the program. And we looked at this through the location when we talked about the actor location, which you can see on the slides prior to this section in 8.7, I believe. Now, return methods are methods that do return a value. And two features are necessary. First, you'll see that the method heading indicates a data type, in the case of the example below, which is a double. And second, that you have a return statement. And the type of value that you return, in this case savings, must match the data type, in this case double. Now you can call it whatever data type you want, between string, integer, double, float, boolean. You can even give it a value of an object. For instance, you could return an actor if you were in Grid World. The only key, again, is that the value that you return must be the same as the value that you say you're going to return. And while casting will work, you want to be a little careful about that so you don't lose accuracy. For instance, casting from doubles to integers, you'll lose your decimals. You have to be careful that you don't lose any significant data. Now, every object has constructors. Our default constructor, if you recall, is simply a constructor that doesn't take any parameters. One is shown at the right, called card deck, which simply instantiates every object with default values of one deck, one player, and 52 cards left. And again, our little shuffle method mentioned earlier, which is a private helper function. Okay? We only call it a default constructor if it does not take any parameters. Now, that said, you can also have overloaded constructors. So in addition to having the constructor from the slide before, you can have the constructor shown below as well. Overloaded constructors have the same name, but they take parameters, different parameters. And in fact, you can have as many overloaded constructors as you want, as your case may fit. In this case, it takes two formal parameters, an integer d, which stands for decks, and a formal parameter int p, which stands for players. And it does a calculation under cards left at the number of decks times 52 to figure out how many cards are left. We could add in more formal parameters. For instance, if we wanted to do the name of the game, we could add in a string as the third formal parameter and pass it along and then create the name of the game as well. Any number of overloaded constructors can exist. If you think back to our phone company, we had a few. The default constructor created default values for transformers down and customers down, whereas we had a couple of other overloaded constructors where you could put in your own values. Now, accessor or get methods are simply methods that return data. Generally speaking, they only need to be created for private variables, which are going to be attributes or class variables that you cannot access outside of the class. So here, the examples get decks would return the private number of decks from the object. Our altering or modifier methods, our mutator methods, for instance savings deposit, are going to modify those private variables. So we go back to our bank example. You have a teller that goes ahead and processes your transactions for you. You don't very often get to walk into the vault and put the money in yourself. Our mutator methods are what can do things like deposits and withdrawals for both savings and checkings accounts. We also have mutator methods under the phone company class as well. These allow you to access the data from your private variables and modify it should the need arise. Now, we're not going to worry about Grid World's main method just now, although you can certainly look at it under the slides that you already have. A little hint for tomorrow. For the rest of the period, go ahead and take your time to continue working on the rational class. I'd like to see it finished by Friday if possible. So make sure you put in some work. Don't give the sub a hard time. And as always, live long and prosper. May the Schwartz be with you. Have a good afternoon. See you tomorrow.